So this packet that we're looking right here, notice it's called Algebra EOC Materials Not Covered Anyplace Else But Important to Know for the EOC. So this is not a review of the entire EOC. This is just some stuff that we think would be helpful for you to know before you take the EOC. So here we go. The first thing we're going to talk about is what's called scatter plots. Now with scatter plots, what a scatter plot is, it's a graph that shows a relationship between two variables. Okay, now there's a lot of graphs that show a relationship between two variables. This one is unique is because it is a scatter plot. Okay, we're not real creative when we come to math as far as how we name things. So a scatter plot is just that we're going to plot some points, and they're going to be scattered, okay? So a scattered plot, though, is really useful, and scatter plots are used actually in the business world and making predictions and everything else. And so a scatter plot is used to show trends of data. Okay, we're going to show trends. Which way is it going and what's happening? And then we're going to use to make predictions. So, for instance, this is kind of beginning, I'd probably call it more like a statistical unit. And this is used in lots of different places. There's actually an occupation called an actuary. And actuaries have math degrees a lot of times. And they then have had to sit for tests. And what an actuary does is it takes the information that it gets in, the data, it collects data, and then it makes predictions about what's going to happen. One of the places that this occupation is used is in insurance. And in insurance, an actuary determines how much insurance would cost according to the trends. So for instance, 16-year-old boys, for some reason, have a higher incident of getting tickets and having accidents. And so their insurance is higher than a 50-year-old male. So an actuary takes the information a lot of times through a scatter plot and to see what the trends are. So this is actually something that's used in the real world in an occupation. So let's talk about the different types of trends that we can see. There are three types of correlations or trends when we look at scatter plots. So the first one you can see here, and think slope. Think slope. I know that's what we all want to be thinking about is slope, but it's cool stuff, slope. Okay, remember rise over run. How much does it go up compared to how much it goes over? So if we look at this one, if we were to look at a line right here, what would my slope be? It'd be positive, exactly. This would be a positive slope. And what an example of this would be, for instance, well, and look at it. See how it increases on the X and then also increases on the Y. So they're both going up. They're both getting bigger. An example of this is the more you study, okay, it affects your grades. So if you study, keep studying more and more, your grades tend to go up. Now, not always. These are just trends and not necessarily going to happen for sure. Okay, but it goes in a positive direction. Now, on the second one, you can already see what is that doing? It's going down. So what's happening is this is increasing. The x-axis is increasing while the y-axis is decreasing. Okay, so an example of this and this is negative. I'm going to put it down here so I have a little more room. So this is a negative trend. Okay, now the thing that's really interesting about these trends, okay, a positive trend does not mean that it's a positive activity, and we'll get into that later. A negative trend does not necessarily mean that is a negative example. So an example here would be the more you exercise, hours of exercise, okay, compared to your weight. So the more I exercise, the weight goes down. So it's a positive situation, but it's a negative trend, okay? So don't confuse negative trends or slopes with a situation. So the more I exercise, my weight That's still a positive situation, but it's a negative trend. Okay, now as you can see this one has no trend. No trend. It's just scattered. It is totally scattered, and it does not have a correlation. Okay, an example of this might be the number of pets that you have, number of pets owned, compared to the number of books. One does not connect with the other. There's no connection between the number of pets a person has and the number of books a person has. There is no connection. Okay? So that's what we're talking about as far as trends. To find a trend in a scatter plot, we draw a line. The trend line that best fits the graph is called, okay, again, not too original in math. This is a line of best fit. Okay? So when drawing a line of best fit, make sure to do two things. For the most part, two things, okay? When drawing a line of best fit, first off, draw a line to follow the trend. Draw a line to follow the trend. And when you're doing this, think about it this way. Try to get about, okay, half the data above, half of data, which would be dots, above and half below. Okay, so we're just going to try to get that. It doesn't always work out that way. So we're going to draw it, kind of look at it, and we'll play with it. I'll show you in just a second. The second thing is, this second one I think is actually the most important. Some people would say that it's not really necessary. But what we're using it for is to make predictions. So we're going to have to write equations. So what we're going to try to do is get the line, when we draw it, to go through or be really close to 2 points. And the reason for that is because it's going to make it much easier to get an accurate equation. So we're going to try for that. So let's look at an example here. Here is a scatter plot. What is its slope? Okay, it's a positive trend. We can see that. As your weight goes up, your height goes up. Okay, unless, of course, your height doesn't go up anymore. We won't get into that. Okay, so now what we're going to do is we're going to take, and I picked a clear ruler so you could kind of see what I was doing. And we're going to try to see what would be a good line. Okay, so it's a positive slope, so we're going to go over that way. It's a positive trend. So we could draw a line right here, and we would have about half the dots above and half the below. But would that go with our trend? That doesn't go with our trend. So try to follow the trend. So we want a positive slope. So let's say, I don't know, play with it. I might choose that line. Okay, can you see that line? I've got some above, I've got some below. Here would be kind of a good line too. See how it hits a couple points there, hits that point there, and that point there. This one, okay, so I could also have a point. This is actually a line, but look, there's no data below, so it's kind of far off. So I would pick something like this, personally. It actually hits 3 points, so that one's pretty good. I'm going to draw this one and see what I think about it. So I could always erase it. Look, I have about, 4 points above, 4 points below. And I'm going through several points. So that's going to be really handy. So that could be my line of best fit. Okay? Now, sometimes there may be a point or two that fall higher or lower than the other data points. These points are called outliers. Now, let me show you what I mean by outliers. Right here, I do not have any outliers. They're away from fall higher or lower. But we did that on purpose. We picked our line of best point fit, so it's away from them. But we want to see that it's close. So, looking at examples. So this one, line of best fit, hits on, good line. Okay, it follows the trend. It approximates, it gets 2 points pretty close. It has some above and some below. This is a line of best fit, and it's kind of hard to see because of the copies. And this person chose a line right here. If I were choosing the line, I'd probably choose about right here. I think that's a better line of best fit. Okay. And if this were my line of best fit, see this little boy up here, or girl, or person, or object? See how it's way away from everything else? Everything else is kind of close to it. This one is way off. So we have an outlier up here. Okay, so that's called an outlier. It's just a little further away. And we'll talk more about that when we get into some statistics. Okay, on the back page. Now, what are we going to use this for? Like I said, we're going to use this for predictions. So if we can come up with the data and write an equation, then we can make a prediction. Because our scatter plots don't, now even look at this one. We only go up to 9 hours of exercise. So what if I did 12 hours of exercise? What would it be? So we're going to make predictions. So what we're going to do here, now that we can draw a line of best fit, we can write an equation for those lines, and then we can make predictions. Okay, write an equation for the line of best fit shown in the scatter plot below. Now, we're going to write our final equations in point-slope form. Okay. Point-slope form. No, we're not going to write them. That's what we want to use. We're going to use point-slope to get it. We're going to write our final answer in slope-intercept. Now, this is awesome that we get to do these problems now because that helps us review point-slope and slope-intercept form. Slope-intercept form, remember, is y equals mx plus b. Point-slope form, y minus y sub 1 is equal to slope times x minus x sub 1. So you might have forgotten how to do this. No problem. I'm going to go through it with you in detail. So we're going to try this first one together, and then I'll let you try the second one. So we're going to write it in slope-intercept as our final answer. Well, wouldn't it be great if we had the y-intercept? But look at this graph. It's probably about 78, but we don't know for sure. So we're not going to use that. We're going to use points because points will give us a little more accurate. So what we do is we look for 2 points. We try to find 2 points that are kind of on the line. I'm going to use this one right here. And what was the other one? I thought this one was pretty close. Those are the 2 that I would use. Could I use this one? Could I use this one? Yeah, that one. Those are all pretty close too. So now let's write that ordered pair. This is the point 3. Now we have to kind of make predictions. If this line is 65 and that is 70, what do you want to say? 66, 67? I'd say 67. Okay. On this one, wow, that looks like it's about 7.5. Oh, that's the reason I wouldn't want to use that line because now I'm going to have a fraction. Can we find one that's more on a line? Ah, let's use this one maybe. This one's a little closer. And why am I not using this one? Because this is the ordered pair of 7.5. I want to stay away from fractions. If I get to choose, and I'm just approximating, choose one that's a little better. So that one's probably about 7.5 and what? Probably about 48. Okay, I can use that one, but let's see if this one gives me a little better. See how this one is 1? Oh my gosh, and 75. So we're going to use 71 and 75. Okay, that just maybe gives us a little nicer number. We can hope anyway. Okay, so in order to do this, we're going to plug it into point slope. So the first thing we have to do is we have to find slope. Remember, slope is y1 minus y sub 2 over x sub 1 minus x sub 2, or you can write it the other way, but you're subtracting y over subtracting x. This has to be the same ordered pair. Okay, so here we go. I'm going to take my point, and I'm going to take 75 minus, 75 and 1 match, and 67 minus 3. Let's see what we get. And if we don't like the number that we get for slope, here's a nice thing. We can actually kind of change it. So subtract those. Calculator. I can get the bottom one. That's a -2. Now on the top one, I have 75 minus 67. So I get 8. Oh, baby. Nice. Yeah. Look at that. We come up with -4. Nice slope. If that would have been like a fraction, I'm going to go back and change the numbers. But it didn't, so yay. Okay, so now what we do, in order to get it into point-slope form, remember point slope, y sub y minus 1 is equal to slope times x minus x sub 1, okay? So the y stays, and then we're going to fill in, and the x stays. Let's fill in the other stuff. Now, which point do we want to pick? I don't know. I don't care. It doesn't matter. I'm going to probably pick 1 and 75 because 1 is a smaller number. So I plug in the y value, which is 75. I plug in the x value. I plug in my slope. Okay. And again, I could have used either of these 2 points. I'm not going to use this one because I'm going to have a decimal. Now multiply this out. So I'm going to get y minus 75 is equal to -4x plus 4. I add 75 to both sides. I get y is equal to -4x plus 79. Oh, baby, look at that. That's a pretty darn good line. Because look at our y-intercept. It looks like it's 79. Okay? So this would be our equation. That would be your equation of this line. Good. So look at this again. We found the slope. We plugged it into point slope form. And then we simplified it down to slope intercept. So we got y on the side by itself. Okay, so what I'd like you to do is I'd like you to write the equation for this one. I'd like you to try this one. Now what I'm going to have you do is we're going to pick a couple points together so that then it makes it a little easier to judge. So if I'm picking points here, what were the two that I wanted to pick? So I picked this one right here because it falls on a line. And I picked this one right here because it falls on a line. So I'm going to make this a point of 3, what do you want to say, 31, 32, something like that. And this is the point of 7. And let's say, what, about 54, 55? I'm going to pick 54. Okay. So let's try that. Find the slope. Go ahead, find the slope. Pause yours. Find the slope. Go. Okay, so you take 54 minus 32. Those are my y values. 7 minus 3. And when I do that, I'm not going to get a whole number, but I can make it into a decimal, so it's not going to be a big deal. So when I subtract here, I get 22 over 4. That gives me 11 over 2, which is a fairly nice decimal. 11 divided by 2 is 5.5. So if we can write it as a pretty nice decimal, that's fine. Don't worry about that. Okay, so you have the slope. Now what I want you to do is plug it into point slope form. Y minus y sub 1 is equal to slope times x minus x sub 1. I want you to plug it in there, and then I want you to get it in slope intercept. Pause, go and do that. Go. So we have y minus the y value. Oh, which point did you pick? We should have picked one together. Oh, well, I'm going to pick this one because it's smaller. 32 is equal to 5.5 times x minus 3. Y minus 32 is equal to 5.5x minus 16.5. Add 32 to both sides. I get y is equal to 5.5x minus, no, plus 32 minus 16.5, 15.5. Okay, there's my equation. Now let's check and make sure it actually kind of matches. This is a positive trend. I should have a positive slope. Okay. Now, why is that important? Because then what I can do is I can predict how much a boy would weigh when he is 12 years old. And if you've ever been to your pediatrician, they have these trends. Now, what you'll find out is it's not a straight line. But if we were just making a prediction, if you go to your pediatrician and you ever talk about height and weight, it actually kind of does this weird little curve. That's because they have more knowledge than we do right now, so they can actually kind of see what's happening and get more data. So what we're going to do for now is we're going to take this, we're going to plug it in. Notice age is x. That is our age, so we're just going to plug it in for x. So we have y is equal to 5.5, and we're going to plug in his age. His age is 12, and then we just multiply this out. 5.5 times 12 gives us 66. Plus 15.5, and that gives us 81.5 inches. Oh, pounds. Whoops, pounds. So when the kid is 12, he's going to weigh about 81.5 pounds. So you can see this is not going to be exact. There are lots of other things that will play into it. Okay, so now let's look at the next two worksheets. Some of these are going to be homework. Some of them we're going to do together right now. And some we're just going to talk about and move on. So the first one says, state if there appears to be a positive, negative, or no correlation. When there is a correlation, identify a relationship as linear and exponential. So just to refresh your memory, I'm going to turn back to page 23. And these are notes that you did last semester. And it's about parent functions. So here's a line, here's a quadratic, okay? Here is a cubic, absolute value, remember V shape, an exponential, a square root, and then the other one is an exponential. Now, this exponential that you see right here, this is an exponential growth. This is an exponential decay, Okay, so an exponential curves up, exponential comes down. So coronavirus, unfortunately, was an exponential growth. That was an exponential growth. And then exponential decay, that one's usually like cells dying off, and that's a common one. So if I see this curve and it comes and it like flattens out, or it starts flat and it goes up very quickly, okay, those are exponential equations. So just keep that in mind. Just wanted to refresh your memory. So looking at these, I want you to take the time right now, pause yours, and see what, write those in. I'm going to do the same thing. Go. Okay, so looking at these, this one's an obvious positive correlation. Because see how it goes up? See how that's a positive correlation? That one's obvious. This one, even though it's a weird one, that's a negative correlation. Okay, that's a negative. And then this one, I would kind of say this one's not. That one's too hard to tell. If it was anything, okay, there's a positive, maybe, no. And then these would definitely be outliers if we had one, but it's not a correlation. This one looks like it is a negative correlation. Okay, and notice how it comes and it flattens out. That looks like an exponential. These are all linear. This one's a linear. This one's a linear. This one you can't say because it's nothing. Okay, and then this one here, this one would definitely be an exponential. Okay. I'm going to skip over these for right now. I'll let your teacher decide if you're going to assign those or not. Look at this one right here. All I want us to do is identify what it is. It says it wants it as a slope-intercept in an equation. So we know that this is going to be an equation. How is this trending? That's a positive correlation. Okay? That's a positive correlation. Now, one of the things I want to tell you about this, if you have tables, and we're going to look at this on the next page, draw your line of best fit, but the advantage you have now is now you have points. You don't have to guess what those points are. Okay, so I'll let your teacher decide that. I want to go to the next page because this is more what you're going to see a lot of times is that what is happening. They're going to give you a word problem and then you have to make predictions. So we're going to look at a couple of these. Some of these we're going to do. Some of these I'm guessing your teacher will assign to you. So look at this first one. The scatter plot shows the number of CDs. Do you even know what a CD is? Compact disc. In millions that were sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006. So look at this trend. See how that's a negative trend? It's going down. So you could make predictions about what it would be, and it wants us to predict what would happen in 2006. Okay? Now, the other thing that's interesting about this is that then people make predictions. But notice the years. This one's an interesting one. We're not going to actually do this one out. But this is an interesting one that is used, okay? And you can see why in just a second. So what happened is the number of CDs being bought went down. Well, look at the years. What was happening during that time? Technology was on the rise. So people started being able to get their music through technology. They didn't have to buy. They could just get it off the internet. They could get it off. And so up here, we didn't have that opportunity to buy music off internet. We didn't have internet. Most people didn't. So the trend went down. So it's just very interesting. It turns out that it does keep on going down. It's a negative trend. This one's an interesting one. It gives you a table and you can plot it, and I'll let your teacher decide. This one's interesting because look at the age of 3 to the age of 15. Huge jump. Goes along as nothing and then a huge jump. This one I'm going to skip. Education. This is the one we're going to do because I want to talk about this one. I think it's kind of an interesting one. The table on the right gives the number of hours spent studying for a science exam and the final exam grade. Draw a scatter plot of the data and draw the line of best fit. I want to do this one for a couple reasons. One is mathematically, see how it gives you that break. So we're going to talk about that. So this is the number of hours studied. Hours studied. And this is your grades. Okay. And then we're going to make predictions. So we'll talk about that in just a second. I want you to pause this. We're going to go 0, 1, 2, 3, 4, 5. I want you to start at 60, 65, 70 is what I want you to use. I want you to pause this and I want you to do it. Plot those points on your own. Go. So if you plotted the points, your graph would look like this. And so you can see it's lots of different places. It's interesting information. We'll analyze it in just a second. Let's draw a line of best fit. And I'm going to do that with a pencil this time. So if I'm going to draw a line of best fit, if I go off this one, that gives me my y-intercept. But then And it kind of follows it. I'm going to actually choose right here. I'm going to do this as my line. So I'm going to choose this point right here. That is the point of 5 and 92. 5 and 92. And then I'm going to choose the point of 1 and 70. Those are the 2 points I'm going to choose. Now, the reason I want to indicate that to you and show it to you, this 60, if I use that, it really, I mean, you could play with it lots of different ways. Your equations, we could all have several different equations, so you just kind of have to pick and choose. But what I also want to show you is once you draw your line of best fit, if they give you the data, go back to those points. Don't estimate your numbers, okay? So we're going to write that equation. We're going to first find the slope. You're going to find the slope, and you're going to find the equation in slope-intercept form, and go. So using those 2 points, we found out our slope was 5.5. I used the point 71, 70 and 1, and I plugged that into point slope form. And I came up with the equation of y equals 5.5x plus 64.5. Okay? So that's my equation in slope-intercept form. If we want to predict the grade, and notice I had to go to other space. I'm sure you figured out another place to work. Predict the grade of a student who studied for 6 hours. We're going to plug a 6 in here. So y is equal to 5.5 times 6 plus 64.5. That gives us, when we do it all out, it's 97.5. So multiply that and add that. So let's talk about what this is telling us. It's telling us that if we don't study at all, we would probably get a 64.5. So the person has at least some brains. If they don't study at all, they're going to probably get approximately a 64.5. That's what we're saying our y-intercept is. Although we already know if you don't study at all, this person got a 60. Then the other thing is it tells us that if we study for 6 hours, we're going to get a 97.5. Okay? Here's a thing that you need to understand about that. Sometimes you can study forever and still not get a good grade. But notice it is a positive trend. The more you study, the better you do. But we also can see here, study 3 hours. One time you get a 75. The other time you get an 84. Okay, so there's a lot of other factors and variables that play into it. So that's the reason this is an interesting one we like to do, but you can see not everything works on it. Could this line go on forever? Not unless you had a test that went on forever and ever in points. Okay, so your test couldn't go on forever and ever and ever. You also can't study more than 24 hours. So that would also be a limit, and your test. So yes, there's all kinds of boundaries on this one. Okay. So on the next page, notice this one. What kind of trend is that? That's positive. Okay, and it gives you what points you're going to use to write an equation with. Here, you're going to plot the points, come up with it. This one is a really good one. So I would try that one. Okay, so check on Schoology with what your teachers want you to do for homework. I know this video is long, but we want to make sure you get in the information. So thank you very much. If you have any questions, you know where to find us.